Orwell was like a research plot just outside Oxford that they used to kind of do calculations on nuclear bombs. And they built this decatron in the early 50s. Then in 1957, it's a competition to see who would get the decatron on. Oh my goodness, you know, wow. This side of the continent.
He came from Bulgaria all the way. Was Bulgaria?
Yeah.
Yeah, I combined a couple of things. That's things for the.
What did you do with that? Change it into AWS? Well, we're going out for some meetings. I'll be around again. Yes, please. Yes, please.
Thank you. Nice meeting you. Take care.
Right, so yeah, that oldest computer in the world, teaching 1957. So basically, people applied for it, and they won a competition to get that research center's old computer. So,
Are they using it for something right now, or this?
oh wait, just for
showcase?
just because it's the oldest working computer in the world. And the guy who was there was telling me just.
Probably not very capable.
Well, no. I mean, but you see, compared to what they were using, and like, you know, it was like for calculating the effect of computing on the and you know, so what would take a clock? This was like 1957. What people would kind of do by hand. It did it kind of many times faster than cooking. And since it still exists as is a lot of input from post office, and at the time the post office included telecommunications stuff as well. So they put a lot of relays in it because that's what they had around as spare parts. And relays are quite rugged, you know, they click on, click off. And so when someone found it in a garage like 10 years ago, people spent years putting it back together, making bits for it and whatever. Now it's back and it's working.
It's working. What?
What's
it? Yeah, I mean, well, it's a question, but there's no technical software on it, or?
Yeah, well, you program it. I mean, you literally kind of flick switches.
Yeah,
yeah. They put the instructions in. Yeah. And I mean, it's quite because it's made with all these Decathlon lights, so you can actually watch it calculate. You can see what it's doing. So it's base 10. So there's a light that goes around as it's counting So you have like a line of like a number that you can see it literally.
Oh, that's all, that's cool. That is, if where it's now. Yeah, that's all.
It's in, actually, that was it, me with it this morning.
Yeah. That's where it's.
Yeah, so that was one of the things that I was. Yeah, 957, they won the prior, the grant of the computer, and it stayed here until I think the mid-60s or kind of mid-60s. Yeah, so now it's.
Quite a long way.
Yeah, yeah. Well, I mean, at the time, no one had anything like it. So it's next up under computers at the time. So previously had one in Manchester. Tell me about that. Was it Manchester Union or Manchester Met went to?
I went there to meet them with the plan, but
You're IBM Manchester.
that's
Right.
stand up, not really.
Right. Yeah, I knew it.
That's the plan.
Yeah. So she's a Manchester shop. So the you do it. Good to see you again.
Yeah, good to see you.
Yeah, that's it. Yeah. Okay. Have that conversation.
Yeah.
Yeah, so there's like a student society. That's the uni now, and I can't be connected by class. Which is a good thing. Doesn't ever get first generation have something like that. But yeah, just to get when the Barclays guys practitioners and that's what matters. But they only want that companies don't do it. I get the impression. You say go first. I don't want it just said, just turn up and we'll ask you questions or something. So it's not as if I have anything. Really? Wow. God, yes. Quite a few. Something. You never know. I might have a little something like you need now. If need be.
I mean, Andrea's read, so maybe we could.
Yeah, actually, let's do that. But maybe that'll buy me a little time to compose myself.
It's an HTML here.
So yeah, shall I come there?
It's up to you.
Yeah, probably easier.
I just wanted to do an icebreaker thingy. But if we go around and one of us tells us, if you were a wrestler, what your theme song would be? What's the very start?
Me?
Yeah, if you were a wrestler, what would be your theme song? Your entrance, yeah.
Đương nhiên là giờ sổ chế vậy để cho phụ. I don't think that really much is. Lots of them coming to go on the stage, you know.
What about you, Herbert?
Well, this is a question I haven't had much time to think about, but I was a wrestler. I had to choose the song to go there on stage. I would choose Wrecking Ball by Miley Cyrus. You came in like a red ball. Very good. Europe. Yeah. The 1988. Okay.
Which one?
Better.
88 something. Song contest. They won the contest with that song.
Yeah, I don't know, we lost one at 1988.
Hell of a song. You know heard it? They got million. There you go.
What about you, Andrew?
Probably go with something a bit hardcore, more like, yeah, maybe a more famous one, Metallica, I Disappear. I disappear. That. You come out in a ninja costume. Yeah, exactly. Disappear. Yeah, that's probably it. Yeah, never thought about it. That's a good question. How do we switch?
This one?
Ah, okay. Never worked it since I guess so. So.
It's not working out. There are no controls for this device.
Let's try once.
But it's there.
So it should be. Picking up. Hang on. No, that's not actually seeing anything. Because when I'm playing it. It's not doing that.
So I'm sorry, it is connected. It's saying it is mirroring.
Yeah.
So probably I have to change from somewhere here.
Well, the.
Maybe just let me try mine.
Story about something that they did.
That's not very okay. That's.
Not much posher since I used to be here. It used to be they had like a projector on the.
The back.
Presented on that.
That was much cooler.
It's more modern.
Oh, there's so many ways that could go wrong. Some bulb goes. Used to have like this remote control that had battery problems. So that is set at HDMI 1. Is that a lead?
So connected.
This is a transaction. Once you, for example, book tickets or buy, yeah, once you book a flight or once you buy a ticket for whatever, this is a transaction. So that's what we mean when we call transactions. Correct. This one I forgot my PowerPoint ticker. Mainframe. So mainframe, those are basically computers, right? Obviously, but they extrapolate all the principles that you learn in computer science to an immense extent. So it's all about when we talk about mainframes, we talk about reliability, we talk about constant availability, we talk about security, we talk about scalability, and so on and so on. Where is mainframe used today? So I'll just click those, make it easier. So most of the banks, card issuers, financial institutions, insurers, telecommunication companies, they use mainframes for their so-called core applications, or in the mainframe world, with the enterprise world, we're saying we're calling them mission critical workload. What that basically means is if something happens with this IT environment infrastructure, and the clients of a particular bank or telecommunication company or whatever, if those clients are not able to process their financial transactions, this can lead to a lot of financial losses for companies. It can lead to, if some of those transactions are being attacked, for example, by hackers and so on, a lot of sensitive data can be stolen, a lot of money can be stolen, and so on and so on. So, in essence, just also to bring things into perspective, basically the biggest companies in the world, they all use mainframe at some point in their, and they all have mainframe somewhere in their IT infrastructure. Couple of probably interesting facts for you. Don't think again on everything. So roughly 70+% of the IT transactions and workload and operations globally run through mainframe. 90% or even more than that of all card transactions worldwide. Not in UK, not in US, not in India, worldwide. So more than 90% of those card transactions, they go through mainframe. This is just also for reference. 8.5 trillion, sorry, of US value is being processed alone. So we're talking about systems which are critical for the financial sector and critical for the global IT environment in general. So why are mainframes so important, right? And why companies choose to adopt mainframe solution? I already said that. It's security, performance, name it, it's all together. It's also especially the latest versions of the mainframe that we can release. They're environmentally very efficient. They save a lot of energy for the clients, which also leads to cost efficiency. And what is the biggest selling point here, and why clients usually choose those systems, is because of the zero downtime. When you see IBM Z, IBM Z is the brand for mainframe of IBM. Why is it Z? Because it refers to zero downtime. The latest Z machine, which is 7E, provides 99.79 after that, after the comma of availability, which means 3.1 milliseconds of unplanned downtime per year. That's theoretical. The practical is 0. This is why companies choose those machines, because they are reliable, they perform at an immense scale, and they are extremely secure. And also, by the way, cost efficient and environmentally friendly. So sometimes you may hear people when they talk about mainframe, they're talking like a total system, right? And what is the difference between x86 environment, x86 server, and mainframe? There are a lot of differences from software layer, from hardware standpoint as well. But in essence, the mainframe systems, they're entirely produced by IBM. So everything, motherboard, chip, processors, RAM, everything is produced with the intention to work together. In x86 servers, you may have, for example, motherboard Oracle, you may have RAM from IBM, you may have GPU NVIDIA, you may have components from other manufacturers. Yes, they are compatible, they work together, but they don't work constantly. And it's all about architecture, right? About the processes that are being used on the motherboard, not how information is being processed, and so on and so on. That particular architecture of the mainframe allows also for so-called logical partitions. What that basically means, this gives the opportunity of the administrators of those devices to split the hardware in logical, so-called logical partitions. And this means every logical partition can be optimized for a specific application, service, or workload of the client. This leads to an increased recording utilization of the system, but this leads generally to increased performance of the entire mainframe box. So that's why we have situations like, for example, with some of our clients, where we have one mainframe box, which is tall as much as I am, basically. So wider, though. One mainframe box can replace 5 x86 servers. And obviously, this leads to a lot of savings for the client. It makes it easier to maintain because you need to maintain one system, you don't need to maintain 5. There are less single point of failures. And yeah. Maybe I'll leave this one because probably too interesting for you. So the first mainframe, the official one, the first official mainframe was released by IBM in 1964. It's called the S360, and it's a machine that was used to land the first people on the moon. You probably, not sure if you watched the hidden numbers. Which one? Hidden Figures. Sorry, Hidden Figures. The movie Hidden Figures. Catherine Johnston. Yeah, very nice. So I'll definitely, yeah. So I'll definitely recommend you to see that movie because it's not exactly a documentary, right? It's a movie, but it's based on the real events. And it's about whole mission and how we basically get to the moon. And yeah, I won't tell much about the story or the whole behind the film, but I definitely recommend you to watch it. Anyway, in that film, and in reality, they used IBM mainframe S360 to do the calculation for the trajectory of the rocket and so on. Mainframe, so probably from that perspective, there is a narrative nowadays that mainframe is old school technology, it's outdated. That's definitely not the case. Right? Like any other technology that we have ever invented, we as human beings, right? It kept evolving over time. Right. And you can see, for example, the latest mainframe Z17 machine. It can process up to million instructions per second. Right? We're talking about almost 3.5 thousands million instructions per second, right? In comparison to the only 54,000. So it has been a journey, right? And it's not all about performance. Right? I mentioned already, it's also about the security. There are the latest mainframe editions. There are also AI capabilities, and I'll talk about them as well because that would be something interesting for you. AI is always the buzzwords nowadays. Yeah, when it comes to the security, I already mentioned it a couple of times. In essence, it's definitely the most secure system that currently exists. Cloud doesn't even come close to it. It's also able to detect, as you can see, up to 97% breaches within the first 10 minutes, which is absolutely crucial for the banking financial sector, as you can imagine. And something else that comes on top of everything is the quantum safe encryption. Do you know anything about quantum computing? Okay, heard about it probably. You keep hearing more and more. I can guarantee that. In the coming years, probably after AI, this will be the next big thing. Currently, quantum computers, they're not available for the public, for the masses, although IBM has one of the biggest quantum computers, and there is an opportunity for anyone who wants to access it. There is like a test on a sandbox environment, as long as you're willing to learn the quantum, the coding language for quantum computing called Qiskit. So you can explore that as well. But anyway, quantum computing is, as I said, probably the next big leap in the industry. You'll see in a couple of years. No one can really say when exactly it will be 10, 5, 10, 15 years, but it's definitely coming. Those computers are extremely capable, but they're using the quantum mechanics, the entanglement between particles, the superpositioning, and so on. And they're really way more effective in performing calculations than conventional computers, like zeros and ones, the ones that you're aware of. And that's why I say, that's why it's very important to provide quantum safe algorithms, because there can be a lot of misuse, if I can put it like this, because there is a dance now called Steal Now, Secret Later tendency. For example, a lot of hackers, they are trying to steal information related to maybe digital assets, any crypto tokens, for example, or financial information, so that they can probably decrypt it later once there are quantum capabilities available for the public. So this is just as awareness for you. You can read a lot about quantum computing and all the theory behind it about entanglement. It's quite fascinating. Sometimes it's also as you read through it, sometimes it's difficult to absorb and apprehend some of those concepts, but it's quite fascinating. So, AI. There are a lot of AI use cases and applications, especially on mainframe and IBM. Do you know what LLMs are? Large language models. Okay, so you know that it takes an immense amount of energy and infrastructure resources to train those large language models and to train those AI models. They are the process is long. It's energy consuming, time consuming, and resource consuming for all the big players on the AI market. OpenAI, Anthropic, Perplexity, IBM as well. So every company that is developing a large language model. Mainframe is becoming quite efficient in training those AI models and large language models. AIM is very capable in implementing and taking advantage of the AI models via inferencing some of the models using the output for the client's benefit. Do you know what is inference? AI inferencing. So, in a nutshell, yeah.
Inference is where it is from existing data and potential for potential based on that.
Yeah, you're absolutely right. So inferencing is basically that's we call the process using new data to already trained AI models and get it out of it. For example, you probably use ChatGPT or some other chatbots or AI bot. So, for example, in ChatGPT, you have the option to maybe upload an Excel file, PDF file, Word file, and maybe ask ChatGPT, okay, summarize the text for me, do whatever with that text. This is inference because you're introducing the data to the AI model, which is ChatGPT, by uploading that PDF file with text. And you're asking it, okay, based on that, please tell me, please give me a summary, or please tell me, for example, what is the next step if I want to do whatever. So this is inference. So AI on IoT is used in all of the areas where basically AI is used. So finance, insurance, government, in healthcare as well. So it can be used for fraud detection, AML, which is anti-money laundering, for risk scoring, for text or image processing, for code assistant or generating code. That's very valuable nowadays as a tool, especially for developers and programmers. And how is the mainframe capable of doing that? Is it because of its latest generation of chips or processors? Good. Those are a lot of characteristics about the processor. I'm not going to mention those. You can always find them also on the internet, but what's this processor very special and also this previous generation, which is called just Stella, second one Stella 2, is that on the chip, on the processor, there is an AI acceleration chip, which is used exactly for those AI inference applications. So let me tell you a story. So usually what happens when you perform a financial transaction using your bank? You perform a specific financial transaction, maybe you try to purchase something from a site, from a website, and the bank infrastructure highlights that specific transaction as potentially fraudulent. Meaning potentially this transaction, because of some predefined features, maybe it is a fraud transaction. So what we used to do in the past, or what is being done in some banks and financial institutions, for example, who do not get Mainframe, is the following. That transaction is taken and the account of the user is being processed so that the transaction can be checked for potential fraud. So the account of the user is frozen, then there is a batch of operations which is launched on the account in order to check historical transactions. And then, after that is being performed, they influence an AI model in order to score the transaction as fraudulent or not, given that information. This is a time-consuming task. And usually up to 30–35% of transactions were being checked for potential fraud. Meaning, the majority of the financial transactions didn't go through that fraud check. Meaning there were some fraudulent transactions that went through. What happens now with this new generation of parent processes, also the previous one? Parent 1, parent 2, the only difference with parent 2 is that it's way much more capable because of the transistors and the clocking power and so on and so on. So what happens on Mainframe, whenever there is a potential, whenever there is a financial transaction which is marked as potentially fraudulent, on one side of the chip, on one side of the processor, that transaction is being processed. Meanwhile, in real time, on the other side of the chip, on the processor, because there is an AI escalation, it inferences the AI model in order to check whether that transaction is indeed fraudulent or not. It's all automated. It happens usually in seconds or seconds. And this allows, currently, with the latest generations of Mainframe, 100% of financial interactions to go through that fraud check. You can imagine what is the difference. Although bank, currently sure, other institutions. Right. Yeah, on the one hand, that 20% of those transactions that are being able to go to that check. The other hand, 100%. So that's why those machines are so important for the IT industry, especially for financial institutions.
So is this AI built in the new C Mainframe?
Yeah. So basically, that's it.
That chip.
That over here, although it looks similar to those, but those are not. So this over here, this is the AI acceleration chip. That does these calculations and inferencing in real time. And this is the real game changer for the business and for the industry. Okay. Because maybe a lot of you have computer science background. So I decided to do some parallels between what you have already learned in Mainframe. So in order to bring things into a bit of a context. So all those things that you learn in computers that you already learned, that you are still learning, it could be cybersecurity, it could be computer science. You learn the same principles in Java. So we have programming, we have databases, we have distributed systems, we have cloud, we have algorithms and whatnot. Everything that you learn as those basics, like in computer science, they all apply for mainframe, and mainframe just does it better, quicker, way more efficient, and at an incredible immense scale. So when it comes to programming, you know, we have all the algorithms, different data structures, concurrency of different batch jobs or operations, transaction processing. So all that you have on mainframe as well. COBOL, you probably, if you get interested to the topic, you keep seeing COBOL. This is the business logic and data integrity behind. So this is the coding language that's the use in mainframe. Because mainframe is very competitive, we work with a lot of open source projects, vendors, and so on. So any programming language, so for example, Java, PHP, Python, it runs on mainframe as well. Wait, oops, sorry. I have
That's to be on.
yeah, I figured. So we have when it comes to operating system. So operating systems, you know, you probably already learned about process, threads, what is the difference there, memory management, scheduling, installation of workload. You know, this security is always there. So ZOS. This is how this is the main operating system of mainframe. Most mainframe clients, mainframe users have ZOS running on their hardware. However, we also have a Linux version. It's called Linux 1. With the latest releases, we have mainframe hardware, but Linux as an operating system on top. It's in essence, it's pure Linux. It's just mold. It has been molded to fit the mainframe environment. So that's our model Linux one. So we have, for example, workloads management, which is used for scheduling of operations with SLAs. We have virtualization and isolation. So every part we go to a previous slide I talked about is those logical partitions. They're very important, right? Because it really allows the system to scale, and it allows the clients and users to optimize their environment. Again, logical partitions, they're dividing the hardware into separate logical partitions, and they're represented as, and they appear on the console, for example, as a separate hardware machine. And it is being configured in such a way that it's optimized for a specific application. And then you have the administrator, for example, that says to create a second logical partition that will be used for another operation or service that the client has. And the configuration of that logical partition will be optimized for this specific application. So this is key here. And again, it also, the principles behind it are the same as what you've already learned, right? Processes, threads, how you schedule those operations, how you prioritize them. This is also very important when it comes to prioritization, scheduling of workload, especially for the banks. We have some operations which are critical. For example, you want to pay at a shop and you mark your credit cards at the counter. So this is prioritized operation because it needs to immediately check what is your card balance, then to transition the money and to encrypt the data while the exchange is happening. But for example, if you want to access your balance just because you want to check something, right? This is not a mission critical transaction or operation. So the world won't lose money if you can't check your balance immediately, right? So this is one. So that's what we mean when we say about when we talk about scheduling and prioritization of transactions. Database. Basic properties. Does that ring a bell? I'm sure you know. Can you learn about basic properties? In essence,
Yeah.
What is it?
it's for, yeah, so it's for relational databases usually.
Yeah.
Atomicity,
Oh.
It's basically the safety criteria. So that.
yeah, so I forgot what's the abbreviation currently?
Atomicity, consistency, and isolation, durability.
Exactly. So that's what the abbreviation means. But the essence behind it is that those principles and those properties, they ensure that the data moves as a whole, that it is secure, and that in the end of whatever transaction the process you're performing, you receive correct data at the end. Concurrency, different concurrency protocols, the data consistency, also recovery and rollback. When we talk about data, those are very important concepts always because everything can happen. A job can fail, or a batch, or a process can fail, but it's important to be able to recover the data for the transaction, or maybe to roll back to a previous state of the data. That usually happens when we do snapshots of our database, the way we're calling it. And in case of, I don't know, some very dramatic hardware failure, and if we lose the main image of the data, we can always do a rollback to a previous version as a contingency plan. DB2 on ZOS. So DB2, this is the relational database that's optimized to run on the mainframe. So ZOS again, this is the operating system. Kix and IMS. So those are transaction engines. I won't spend a lot of time talking about them because probably to lose you. But yeah, they're probably older than most of your professors, probably older than you. Yeah, but
60th anniversary, didn't we, a few years ago?
yeah. But yeah, yes, they are old as transaction engines, but they're quite efficient and they're much faster than most of the models actually.
60 years worth of development done.
Yeah, oh yeah, that as well. Yeah, I mean, they kept evolving as well, right? So, I mean, yes, their initial version was 6 years ago, but now it's they're a bit different. Networking distributed systems. So distributed systems is probably, mainframe, way before clouds existed as a concept, provided the possibility for distributed systems. So in essence, mainframe was the very early version of cloud. I have one or two slides about that as well. But when it comes to networking distributed systems, so you know we always have a client server type of model, right? The clients, those are all users. Obviously, server can be referred to either mainframe, you can also refer obviously to x86 or even database. We have latency, throughput, fault tolerance, all those concepts. They're embedded in the mainframe environment, and architecture as well. Mainframes, they're so-called core of those global networks of banks, retailers, airline companies, you name it. In most cases, clients, they have so-called hybrid clouds. Not sure if you have heard about that term, but hybrid cloud is in essence combination of cloud solution and native or on-premises infrastructure that the client maintains. And most clients, they have combination of both. So that's why they're called hybrid cloud. An example, you get bank accounts. When you try to access your bank account through your mobile phone or to the web browser or whatever, you're accessing maybe an API, some sort of API. This can run cloud for the client. But if you start initiating financial transaction, then it transitions to a mainframe. So most clients, most banks, most retailers, then they have combination of both.
Okay. So
The constant battle between cloud and mainframe. Both have their, as I already mentioned, most of our clients have combination of the two. I definitely cannot say which is better, right? Because they just fit for different purposes. Yes, for example, mainframe is much more, I would say, better when you compare it to concept of availability when you compare it with cloud. Cloud can reach up to 5 nines, 99.999 availability. While mainframe obviously much better. But basically everything you have on cloud, you have also on mainframe. So the virtualization that happens on cloud, those are the logical partitions that mainframe has. Containers, we have containers running on mainframe for, I don't know, ever since. Workload isolation, cloud can definitely scale horizontally and vertically up to a certain point. And then it starts getting, as you scale and as you grow, it starts getting very expensive for the clients. This is also one of the benefits from mainframe. Again, you can scale both ways. Zero trust security, do you know what's sorry, I lose a lot of terms here, but I'm trying to explain something, not here asking a question. Well, do you know what zero trust is as a company? So zero trust is basically a concept or approach that regardless of what type of operation we are processing, we are treating it with zero trust, meaning every single operation is potentially fraudulent. So we need to treat every transaction, every operation as potentially fraudulent. So this is what zero trust means. It is in a way embedded in cloud, but as already explained, it's way more faster on mainframe, right? It's that addition of the AI chip on the processor, but it's doing those AI inferencing in real time.
okay.
What is the HWNS token?
Sorry.
What's the HWNS token?
Oh, sorry.
Yeah. Sorry, I'm so used to abbreviations. So hardware and software and for security. So yeah, it has both. So it has hardware encryption as well as software encryption as well.
Which one in terms of?
Combination of both. So definitely combination of both because cloud provides software. while Mainframe we have the hardware as well, which adds an extra layer of security. It makes it much more difficult to police content, so to speak. Okay, so well, a lot of logos here, but in essence, what I want to show with this one is everything that you probably already learned, all those skills, and this is just some of them, right? Some of the vendors that we partner with and that are compatible and are supported from the mainframe. If you have any of those skills, and again, this is not just an expensive list, this means that you don't need to start from scratch if you want to get into mainframe, because all of that is transferable and it exists on mainframe. So, for example, when it comes to cloud and containerization, I mean, the biggest, the most famous ones are Docker, OpenStack, Kubernetes, OpenShift, Terraform, it all runs on mainframe. When it comes to programming, I already mentioned earlier, Python, Java, Node.js, PHP, like Scala, Ruby, all those run from mainframe as well. When it comes to databases, not sure if anyone has already explored that area, but yeah, it's MongoDB, PostgreSQL, MySQL, MariaDB, CouchDB, it's my favorite one because of the name CouchDB. Yeah, and many more. And it's again, it's all supported on mainframe and also. Yeah.
The other time you said, yeah, it's what's it? Quantum computing as well as like ready to do the programming language. So my question is, can I go to like JavaScript or PHP on one of the different cloud or
On the quantum, no. So the quantum is definitely not. The only thing that you can run there is the Qiskit, which is a special programming language developed for quantum computers. You can't because it's a very different concept and logic. Fundamentally, absolute fundamentalism. We have links for that. Yeah. So, yeah, I did a cost. Do you know anyone in Shropshire or Mainframe? I'd love to know if they are. Yeah.
Does anyone write closure on real life?
Yeah, all time. I know companies, particularly fintech. Yeah, I was, yeah, not, there are not a lot, I agree. There was engagement, yeah, we should. Yeah. And one of the teams that I'm also leading, they are responsible for helping all those vendors for their software application, whatever. So we manage the entire relationship with them. Obviously, we strategize who are strategic partners, vendors you want to collaborate further. So some of them we support maybe only because of one particular very big client who asked to get that support. So yeah, it's heavily client also.
Going way back with the land community, I know things like Chef, CouchDB, private equity, they all use the land underneath. So I guess that's.
Yeah. Okay. So, and when it comes to skills, again, a couple of numbers here, but you can forget about those. In what I want to say with that slide is there is high demand
for people with mainframe skills right now. The majority of the specialists, they are retired, or maybe not the majority, but a big portion of them are retiring soon. And there are also a lot of companies, not only IBM, but also Batali here is okay, and we have Waves, different organizations who provide education, academies, they organize a lot of events, they maintain a mainframe community in order to promote the platform, the technology as career area and career development. There is high demand on the market for mainframe skill. And if I have to be honest, it's easier for young talent to find a career in mainframe than in the majority of the other IT industries, because there is less competition also in mainframe. It's not that popular, although, as you saw, the majority of the IT infrastructure is on mainframe. Majority of operations, 90% of car transactions are on mainframe, and companies are not migrating away from mainframe. On the contrary, they keep investing. So that's why they also keep looking for additional people who will join their company to help all these things, maintenance, supporting the platform, developing, and so on. So, if you're interested, yes.
I have a question. So between mainframes and let's say the traditional like data center towers, like the server racks and stuff. So what's like the main advantage of mainframe, or what's the main difference between mainframe and a standard server?
Yeah, a lot. So performance is one. Efficiency is the second thing. It's way more secure as well from hardware and software perspective. And the architecture behind mainframe is very different, right? So I was going back to what I explained, because when it comes to x86 servers, we have different manufacturers of components. While mainframe is developed from ground zero as a single unit, single machine. If I can give you an example, when does anyone have Apple? Is anyone using iPhones? You probably know that once you join the Apple family, right? The MacBook, iWatch, iPhone, on iPad, everything is so well integrated. It's seamless, right? You get a message on one device, it pops up on the other. You can unlock your MacBook if you have an iWatch just by your hand staying near the laptop, stuff like that, right? It's very similar with mainframe as well, because every single component, the software, they're specifically developed for that particular machine function, but it's single. Also, those capabilities for logical partitions that I explained. The AI inferencing chip that I also talked about. So those are all elements that definitely are different from x86 and what makes it much more efficient. So again, it's more productive than x86, so performance-wise it's better. Security-wise it's better, so it's also less expensive to maintain. Imagine if you have like one mainframe box, which is that big, then you replace with this one box 5 x86 boxes. So as a company, you save on storage space, lab space, maintenance as well, energy and extrapolate that to an immense scale as those global corporations usually operate, it's different for them. It leads to millions of savings. Millions. And they are saving money. It is more secure. It's fast. So that's why all those banks, right? They're using them. They're not migrating away. They're, on the contrary, they're keep investing in their infrastructure. In UK, Lloyds, HSBC, NatWest, all banks based in the UK, they have Lloyds, all of them.
Yeah, well, that's, if you've heard of them, they probably is a move.
Yes. And also, for example, all airline companies, they also use Mainframe as well, especially for the financial transactions. And to run, there is a software that it's called Amadeus. It's
I know it is.
yeah, it's the software that most, if not all, airline companies use for bookings. It's a software that I don't know what's the 60s.
We had Sabre, which was on the special.
Yeah. So yeah, that software again is probably 60, 70 years old. And so there nowhere I can experience it because it just worked immediately real time. And again, yeah, that runs also on Mainframe.
I was,
Yep.
you said earlier about, and we've heard this in other events and stuff, like how mainframes are quantum safe. How did that really work? Like, how do you use quantum safe? Quantum computers are not even real thing yet.
Yeah. Well, IBM has a quantum computer. It's, I think, one of the most powerful ones. Unless there is a quantum secret one. For example. Sorry? There's a few every year, Microsoft, Google, IBM, we all announce different versions of our own quantum computers, and every announcement comes with every next quantum computer comes with more qubits. The way we measure the capability of a quantum computer. So it is because of the quantum safe encryption algorithms that we have implemented. They're patented. We have, for example, do you know what state device is? State library.
Tape plan.
Yes. So
Storage.
yeah, storage. VCR was it
Yeah,
VCR?
yeah, but the young men, they probably wouldn't have remembered.
Yeah. Do you know what VCR is?
Yeah.
Yeah, exactly. Those tapes. So it's the same technology. Like for example, like the Walkman, the cassettes people use for the Walkman, that's the same technology. Magnetic storage, in essence. And tape is it's being used in enterprise to archive data. So all the banks and all big corporations, they all have very big tape libraries, which are a bit futuristic because you have automated robot hands that move the tapes, the tape cartridges, and so on. And they use them to store data. Why? Because it's energy and cost efficient. And in the financial industry, there are a lot of regulations that require bank companies to archive and store data, maybe, I don't know, 20, 30 years, some countries even more. And it's way more cost efficient for them to write it once on tape, magnetic type of data storage, and then store it somewhere and keep it there
it can be into reference. Because if they use standard, let's say, hard disk or flash type of storage devices, they require power and energy to run, which is not cost efficient for the price. Anyway, I started from one point and got to another, but we do have also quantum safe encryption on those quantum safe algorithms on archived data on tape cartridges on tapes. And again, it's beyond one case. So yeah, it's all about the algorithm behind it of how the data is being archived and secured. The algorithm itself, I can't explain how it works.
Shaw's algorithm. Shaw, yes. But basically, most encryption based on factorizing primes relies on the fact that it's too expensive for you to go through and translate them. Of course, quantum computers work slightly differently, so they have like three-value logic. That's no longer true. So it's not as expensive to factorize primes in the same way. And so the quantum safe, you're using a different algorithm that isn't relying on factorizing primes. So it's working against how a quantum computer works, as opposed to assuming that factorization is too expensive. That's one of the truth. But download the quiz kit. There's some stuff about it in there when we get into that.
Just a quick question on follow-up from your answer. So you said you currently use those type of tapes for archiving. So in terms of like a standard runtime, like during its operation, is it the tapes it is currently using for processing, or it's using its normal solid state drives to run?
Yeah, so valid question. The tape storage system they use on for archive data because the read and write speed is input to the technology, right? Because you have a physical reader or writer, right? That writes or reads data from or on the magnetic tape. So it's very slow if we want to use that type of storage for ongoing operations and yeah. So when it comes to data storage on mainframe for processing and information, it's always flash because of the fact zone.
Yeah, but when you said like 40 terabytes, that's RAM. 40 terabytes of RAM.
Well, that's RAM.
I just wanted to get the different because it will be moved from the flash states drive instead of.
Yeah, but like a lot of things, it's like a constant arms race. So as you have more capacity, spin it really quickly. It's a really good for a lot of time. So that's when you need back. And so when something happens, we need to get it back. Spin that up, put that in increments, and then get back to the thing of it.
Yeah.
Is it okay to wrap up in a few minutes?
Yeah. Okay. So two, three things very quickly. So if you want to start from somewhere to learn a bit more about mainframe concepts, I'll definitely recommend you to visit this platform. We're calling it IPMG Explorer. It is completely free of charge. All you need to do is register with an email. I would recommend you to use a personal email because if you complete the educations there, complete the hands-on labs or the challenges, you will get those badges. And those badges are issued to you against your email address that you registered with. So
That's why I recommend to use personal email address rather than the one I have from the university. That way you always keep your badges associated with your account. In essence, on this platform, you'll be able to go through different education paths and roadmaps, concepts, advanced and all-star. There are 3 badges that you can obtain with 3 different roadmaps to complete. The content there is very carefully curated, so it consists of some theory that you can go through with your own pace, and you have also the opportunity to log into a real mainframe. There is a sandbox or a test environment, and some challenges that you are asked to perform on mainframe. So you have the opportunity to create an account there and experience from first hand what it's like to work on a mainframe machine. There is a forum community. Every time you have some questions, issues, you can always send a message there, and yeah, the colleagues will come back to you. So yeah, you can scan the QR code, access the portal, do the registration later, but maybe you can scan it now if you're interested. So this is probably a good starting point if you want to learn a bit more about mainframe. And you get something to show for it. You get those badges. By the way, they are industry recognized. So everyone in the mainframe industry, once they see those, they can recognize them. They know what step education is already for them.
So if I have all these badges, will I get a job?
Well, it's definitely more likely to land a job mainframe if you have those in comparison to others, because again, when it comes to mainframe, it's not very popular for potential career. I can't really comprehend why that is the case, because you're at the edge of technology.
People don't know about it. They haven't heard about it.
Yeah.
They think it's old.
They don't even.
And it's not.
It is old.
It's literally at the edge of technology. We have everything, AI, coding. I mean, everything I already talked about. The community is great, especially in UK. The community is really active. There are student clubs in different universities in cities in UK. A lot of events organized by some of our clients, the banks, or some of our partners like Vertali, BMC, Broadcom also organize events, Waves, Next, you name it. So the community is really great, very supportive. They always welcome new people to the community. That's always a positive. There are conferences like GS UK, which happened last year. You were there, and yeah, Herbert as well. So it's again it can be very fulfilling as a career path. There are different areas which you can choose. So it's when you join or when you choose to pursue career in mainframe, there are very different paths that you can take. You can become a security specialist. You can become a database administrator on mainframe. You can become application developer on mainframe. You can become mainframe administrator, operation specialist. So there are very different job opportunities depending on what you really like doing. If you like more coding, then application development or system programming is another thing that will be probably more interesting for you. If you're into database administrator on Z,
we work with Oracle, with all the biggest database providers as well. So a lot of opportunities. And to your question, there are literally, and I had a conversation last week also with a colleague from Vertali, which is one of the biggest partners of IBM here locally in UK. They have, I think, already hundreds of mainframe specialists in their company.
Including a number of university.
Yes, yes. And I was talking to a colleague from Vertali last week, and they told me that they have more than hundreds applicants for one role. And this is only on CV. And you can imagine how challenging it can be for someone in HR or hiring manager to filter all those 100 plus CVs only for one role and select one person. Okay, maybe they give a chance to 2 or 3 people for an interview, but at the end of the day, they have to select one. But again, they will interview just a very small percentage or number of those people. So you have like more than 100 people for one job, for one role. Maybe you invite 4 or 5 people for an interview. So that's like 5% chance for you to be invited to an interview, and then also even less chance to be chosen for the role. Badges like those, engaging with the community, building some network, joining some of those conferences, activities, events, definitely gives you some advantage in comparison to other applicants who don't have that. haven't done a bit of haven't invested some of their own time, right, to go through some of those training educations. And especially in situations like this, when we have to filter a lot of people on CV, badges is one of the one of the things that is being looked at. Okay, does that person have some skill already? Did that person already show some interest in engagement in the technology? Has that person completed something? Is there something you can work with? And if they don't see that, maybe they choose another candidate who probably maybe at least one of those badges. I don't know. But yes, they don't guarantee you a job, but definitely, but nothing does really. But this definitely opens the door and creates more opportunity. And the cool fact is it's completely free of charge. And it's, again, well structured. You can go on your own pace. You don't have time limits to complete the theoretical training or the challenges, the hands-on challenges and the lab exercises. You can do that in your spare free time. You can do that in your free time whenever you have some time to dedicate to it. I think maybe for this one, I think it takes like, it took me 5-6 hours to complete everything.
Are you serious? It took us a whole semester, but we were like taking 1 hour each week, so.
Yeah, okay. To be fair, sorry, but to be fair, if I have to get started, I know some of the theory behind it, I already know, I just need to perform some of the labs. But yeah, if you really find it interesting, dedicate maybe a couple of hours every week now and then. Yeah, you can get all those within a semester even. Yeah, they'll just explore advanced one. I also they become more challenging. Okay, so once you complete the previous challenges and trainings, we'll share the slides where you have those links, QR codes. Next step for you, if you really want to continue developing further, is to access the Mainframe skills depot. Some of the content there requires subscription, but there is a roadmap, IBM Z101, which is like 90 plus hours of 96, yes, hours of structured education, which is completely free of charge. And it covers the majority of the mainframe components, obviously the basics there. And again, you get tons of badges when you complete it. And I'll definitely recommend going over it if you're interested and if you've completed the previous explore. This is kind of overview of that IBM C1 roadmap I was referring to. So computer science principles, you have GOS, AI introduction to enterprise computing. So a lot of interesting content there. So some of the things we briefly talked about today, they are there, obviously more details. Hardware tour of the machine to understand more about what makes it stand out in comparison to x86. GOS and Unix basics as well. Okay, and if you have any of those badges, you can you can create a profile here on Mainframe Career Depot. This is a job portal that IBM sponsors and we maintain for careers within Mainframe. And it's not, we sponsor it, but it's not IBM, right? Yeah, we may post job opening there as well, but the intent is that we want to make it easier for our clients, partners, companies to find skilled talent, and also vice versa. For people who are looking for a job, to log in there and find all Mainframe related roles and postings in one place. So again, Richard, you can create an account as long as you have one of the Z-Explore badges. So you have to show something for that. Okay, and this is the program. I guess you probably discussed that in the past.
Achieve on the program right now.
Okay, cool. Okay, so I won't spend much time on this one, but yeah, basically Afrin and English, they're part of the, oh, yeah, yeah, sorry. They are all part of the IBM Student Ambassador program, and they can, I won't spend a lot of time, I don't want to waste it, but you can also talk to them what it's all about. We're always looking for new people to join it. At some point, you have to hand over the torch.
Yeah.
As you move forward, so yeah, it can connect you with student ambassadors from other countries, from other regions, universities. We do education, a lot of sessions, guest lectures. But yeah, you can talk more about that. Okay, so that's it. Any other questions? It's a lot. But that's what makes it, right? It's a technology which is being used for the most critical processes, for the most critical transactions. If something goes wrong, it first costs millions. Fraud costs millions as well. It's a bit sometimes can be a bit frightening if you are the person maintaining the system, but that's what makes it really interesting because this is the backbone of the industry, of the industry generally. It can be a challenging, fulfilling career. You can always learn more. AI, clouds, networking, distributed systems, spread systems, coding, programming, application development, databases, everything's there. Okay, well, hope it was interesting. You can reach out to me in LinkedIn as well. So, next. Thank you. And thank you for having me. Thank you
for doing the talk. We'll take a 10-minute break. Because yeah, it was long. Go to use the restroom. This is how it must be. If you guys want any drinks, there's glasses and soda.
So we can at least try and see if my slide is clean.
Yeah, it's here. Don't worry. I've got the slide.
I sent you some pictures of it.
Oh, pictures of them. I've got the one from mail. Sorry, I was just talking to.
Yeah. So is there, I think I sent to your email some pictures.
Some pictures. Let me check. That one is for the TV. It's not here.
Oh, it's definitely something. So it's got like a link on it.
Oh, wait,
Pics.
there's this.
Select pics. So go to that one.
So you want to show the pics as well?
Yeah. Well, if
I
you
should
download
link
them.
to my
Yeah, we'll
to the PC.
yeah. Set them somewhere. Show this first.
And the pictures first. Let's give it a sec. It's not my way over. Found it. Do you want to use them?
Download those ones and I'll just open them with them.
Oh, okay.
Download that one, I don't know what it goes.
I'm sure. Oh, baby. This baby was. Yeah. Yeah, I'll give it to you. Give me a second. You're so impatient.
It's been 3 months.
I give you Ben in the morning.
That's all here. Hang on. That's what it is. Yeah. Sure. Let me know when you're ready. Oh, these are food. I will explain. It's food.
No, it's not food.
No, no,
I'm
look it up.
curious now. I don't know what they've got.
It's not food. No, it's not. If I can't eat it, I don't know what it is. That's the first check. Absolutely not.
You guys want any drinks?
I'm okay, actually. Fine.
Need to share the slides here as well. Oh. Hi guys.
Hello, people.
Four. There were like 8 before, now it's 4.
Well, you see.
No.
No.
Adam says.
No, they came specifically to see you. And then they were there. Who's that other guy?
Adam says hello.
Oh, hello, Adam. How you doing?
Do you guys have any questions?
We'll get to questions. We'll get to questions. All will be well.
Yeah. What? Yeah, I'm just loading the presentation. My phone here, I guess. We're ready when you are.
Righty ho. Hello, people. Can you hear me? Hello at the back. Hello at the back. How many of you know that this here room, this exact room, was the founding room for the university club that you're in now? Hands up if you knew this. See? Yeah, I found out today. How these truths slip away. So, let me show you some of the signs and wonders. So, Valentine's Day 2019, we had a special workshop here run by this good friend of mine. Any of you recognize this guy? Yeah, his name is Henry Kuiper. Among other things, he was the founder of the Mainframe Society. And he gave a special 2-day workshop here called Introduction to the Mainframe Software Stack. And so those pictures there, that was on that whiteboard there. Maybe if you squint hard enough, you can still kind of see them. Okay. So mixing up my mouses. So this is a group of people who came to visit us during that 2-day stint. How far away do you think they came from?
Germany.
Germany? No. Definitely UK.
Oh. London.
No further than London.
Scotland.
No, not quite as far as Scotland. They actually came up from Bournemouth. Who do we know lives in Bournemouth? In terms of companies. Okay, so these are guys from a bank called JP Morgan. Hands up if you've ever heard of JP Morgan. Oh, that's good. And they came all the way up to Wolverhampton to see little old us because they heard that we were having a little learning session about the mainframe. One of the things that they find, the JP Morgan mainframe team, is they struggle to find good people. Right? People fall over themselves to get into JP Morgan, right? But finding good mainframe people who can do what they need, that is actually a challenge. And on that basis, they were prepared to send 4 people up by train just to see a group of start mainframes. Still have relationships with those guys. In the middle, in between, it looks like 5 of them. That is actually 4. Who or what is that?
Cyberman.
Ooh, someone's on the ball there. Oh, hang on. What did I do? Where did I? Ooh. Need to Alt Tab that and bring that back. There we go. Yeah, well, we were taking them young that day. So that was our original mascot. It was a Cyberman. Ever been to Forbidden Planet in town? So it's now moved from where it used to be. Now it's in the Wolfram Centre. They were doing a sale, and I got that Cyberman for, I think you can actually see the price tag up there, 99 pence. It's like a human-sized kind of Cyberman. And from then on, we kind of had a little bit of a Doctor Who theme. And there's a whole thing about mainframes being like a TARDIS and bigger on the inside and all that good stuff. So in celebration of that, I have a little something for everyone who attends today. And some, I will be leaving some with the people who run the society. Are you going and coming back? Or yeah. Okay. So I'll keep yours. So we're going to see who's in the cricket club now. We're going to see who can catch. So these are, sorry, that was a bit. The rest of you, unless you've got your teeth guards in, right? Oh, well done. The cricket team. They're not correct, are they? Very good, very good.
I don't know where it is.
So, look these up, Google them and see what they are. But these are kind of classic Who era memorabilia, and for special people who like the platform, your club leadership will kind of share them out. So when you do things, when you finish these badges, when you turn up, they will have more of these for you. We have thought ahead on this. Yes, your eyes did not deceive you. You did see a baby. So on the day, among other visitors, we had a baby come along and have a little go at mainframes. And even, I think I even have a little tiny bit of footage.
He's still showing a very apparently.
Yeah, by now he's got it. Yeah. Quite a bit quick. So we had a bit of fun. We had a bit of fun those days. So I want to give you a talk, which I gave another day, in another location, and it's called the mythical mainframe. Because when Andre asked you at the beginning, how many of you know what a mainframe is? And none of you put your hands up. I thought, you lazy beggars. You lazy beggars. You are up to the mainframe is. In fact, people who don't know what a mainframe is, know what a mainframe is, right? They have a thing in their head. The same as if you've never used a robot, you know what a robot is, right? Mainframe, robot, these are cultural kind of terms. Right? You have this idea, it's a big computer. Right? That's a mainframe. And so I wanted to talk a bit about this inherent sense we have of what a mainframe is, why we have it, why it's kind of embedded in our kind of background, and what the real mainframe is all about, what that story kind of tells us. So I was doing this in 30 minutes, so I was racing against it, but ignore that. I was kind of trying to get some love in the room for an old computer that I grew up with, but you have different old computers. So, everyone you know has an idea of what a mainframe is. Now, as Andre was explaining, everyone is used to one, whether they knew it or not, right? Every time you've made an online payment, every time you've got some money out of a hole in the wall, you've been spinning the wheels on a mainframe. And this was kind of an old advert for kind of software in one of the old school kind of magazines. The elephant that dances. That's our mainframe. So this fella, ignore him. And until very recently, that would have been a completely different picture of a completely different institution. Can you guess which one? No. But there we go. So, all these words, this is word association and mainframes, right? What kind of things all kind of come together? I'm guessing pretty much any one of those, if I said word association, I said mainframe, you might come up with one of those, right? This is embedded in most people's head. Ask your mum. Everybody kind of knows what they is. So I'm a little interested in for why. So the term mainframe itself, we have it as one word, but it was technically kind of two words. So in the early days of telecommunications, you literally had a frame that you hung the processing bits on. And the one that had the most on it, the one that did the core of the processing, was the main frame. And that's kind of where the term comes from. Now, similar with telecoms, all those things that Andre was telling you about how reliable they have to be, during telecoms, those are legal requirements. So the fact that mainframes that we know, IBM mainframes, and kind of telecom systems with high availability requirements have a lot in common. That's no surprise. That's no accident. I didn't just kill the online thing here. Try and make sure. I pressed a button and they all disappeared. Do Alt-Tab. Hang on 1 second. Did you just check I haven't murdered everybody online?
You did murder.
I did. Okay.
It's okay.
Whoops. Okay, now that's. and we're back.
I'll just sit down here.
Okay. So, know what a mainframe is, even if we don't know what a mainframe is. A mainframe is a very good plot device. Hacking the mainframe, Zion mainframe. Actually, video of montage of lots of different things that kind of breaking into the mainframe. So we know it's a thing. We know it's where good things happen. So I want to talk a little bit about the mainframe, rather than any the mainframe. And this is the IBM 360. So some of these things, guessing your family, when you're doing or so actually, it was of so and kind of points of this, but there are some challenges and I'll say a bit about the background and the here that large company that was this was to otherwise business. So when people who uses mainframes then? Anyone who serious business probably use as you know. Okay. Keep going. So this is basically what I was saying before. All about. This was very bonding. Perhaps an costs. So probably baked into the cost. At the time. So the 360 out project.
Oh. So what made it so actually some backwards compatibility. There are going to be different peripherals that are compatible with it. You can upgrade if you need to, and you won't have to change the software or your data. You've basically forgotten it. That was kind of that was business proposition. This is computing packaged up so safe that you could put your precious kind of data there and not have to worry about what's going to happen in the future. Oops. Bang. So of course, because of the kind of the influence there, and that was the CEO at the time, Thomas Watson Jr. It basically created a new ecosystem, and that's a term that is also in Andre's job title. It's a computing ecosystem. So in the same way, Macs are an ecosystem. You know, specifically when you use the Safari browser, you go, oh yeah, that's a Mac thing, kind of thing. Mainframes, IBM mainframes are an ecosystem. You know, they do things differently there. But creating a whole new product line involved all sorts of other things that you had to kind of do as well. So there was a brand new operating system that you had to come up with, a control program. You had to find ways to integrate all these different configurations and figure out what are the features that make sense. How do we bring people on board, and how do we support them as they go forward? But despite quite how bold this was as an idea, it actually became very successful. The story goes, and you can see some of the videos online, the first 2 months, they literally had no orders at all. Very nervous executives. And then all of a sudden, the orders started rolling in, and they sold 1,000 in the very first year. And so a lot of organizations, this was the very start of the computing age. They've never had a computer before. It was all on paper, and you had like clerks who were working on these big kind of rolls of paper in kind of offices. This was the first time that a lot of companies started to use computing seriously for business. Oops. So some of these gents you might know because they were quite influential. Have any of you, I was going to say, have any of you heard of this book? Have any of you not heard of this book? Boo, boo, shame on you. So The Mythical Man Month is the fundamental book on software development at scale. And it was written by Fred Brooks, and he was the architect, or one of the architects of the 360. And Brooks has this law about how adding new people to a project when it's late actually makes it later. And it's one of these kind of once become one of these standard stories about, you know, how computing, project management for computing actually works differently for lots of other areas like construction or something like that. It's a fundamental book if you want to understand software engineering. So, but it was basically the story of how he and his team made the operating system for the IBM 360. So it basically invented industrial strength, mission critical computing, because until that point, it was all a little bit hit and miss. But IBM said, look, we got you. We're going to underwrite this system, and we're going to put in all the features that mean the odds of something going wrong are minimized as far as we can do that. And it's a platform that has now 60 odd years worth of experience in making sure that things keep running. All the possible ways that things can go wrong, mainframe engineers have seen them, and they've had to mitigate against them. Did you ever see the video of the earthquake tests? No? Okay, I've got old. Yeah.
One of those shakers, yeah.
Yeah. So all sorts of things that could possibly go wrong, they've thought about it, and they've thought of ways to manage the risk.
Didn't that survive like a magnitude 8?
What?
Didn't that survive like a magnitude 8, a simulated earthquake?
Yeah.
Quite incredible.
Yeah. No, definitely. Interesting. And it spawned a line of proprietary software. We love open software now, but at the time everybody loved proprietary software. But it was proprietary software that could evolve. It was getting better, right? So it goes from one generation to another. So we talk a lot about ZOS. If we're getting biblical, then it's kind of, OS 360 begat OS 370, begat MVS, begat OS 390, begat ZOS, right? So that's the and the teams that were creating that were learning all the time. If you ever get down to GSE, some of the guys that actually make all the latest versions of ZOS are there, and you'll see some of their slides and their updates. It's some seriously intense stuff. The stuff they do with drivers, the stuff they do with memory. It's some highly evolved software. Let's put it that way. And mainframes fundamentally give us the centralized model because they were so secure and because they were so expensive. We had to find ways to share them efficiently, and this meant we had to bake all these things in as the standard. And we also have this thing about we can do that because if you own the whole stack, you can make it dance the way you want it to dance. But because there was only one machine and it was central, it had to be fault tolerant in all kinds of ways. You couldn't just go, oh yeah, I'll spin another one up or turn it off and turn it on again. It had to be designed in ways that it could be kind of shared and compartmentalized. So all the design features there. It is the only commercial system that conforms to American Department of Defense Orange Book standards in terms of how you can secure it. And that's still true now. I say literally revolutionary. This is a guy called Salvador Allende, and he was the president of Chile back in about 1973, and he invited a British management consultant, a guy called Stafford Beer, who used to do a lot of work over in Birmingham, to come up with a system so they could control the Chilean economy from this one room in Santiago. It was called Project Cybersyn, and it was literally revolutionary in terms of they were kind of getting the information about where demand was in the economy, trying to match it with supply. Now, those of you who know a bit of history,
No, that maybe didn't end so well. There was a guy called General Pinochet who took it upon himself to put a stop to that. But it was interesting that if you read the book, there was an IBM 360 that was at the center of that was processing all the data from all the factories. So, question: when you have a CRT, why does it have 80 columns? Well, because in a punch card like this one, which was used on the 360, you have, guess what, 80 columns. Okay? And each one was potentially a character. And that's still true. Right? Why do you have 8 bits in a byte? Because the IBM 360 did. Before that, there were good reasons to use 4-bit bytes. 7 bits, you could get all the ASCII in. We standardized around 8 bits because the IBM 360 did. So had it not been for the 360, would be counting storage in a completely different way. And at the time, memory was physically very expensive. So using an 8-bit model as opposed to, you could get away with kind of 6 bits. That was, something I think so that's quite extravagant. But as far as they were concerned, you wanted to have enough different types of characters because it was a business computer rather than a scientific one that you could represent uppercase, lowercase, and all the characters and have a little bit of room to spare. So part of the influence of the platform. Back in the 70s, because as we say, these things are very, very expensive, you had to load them up as much as you possibly could to get the best use of them. And that's where the ZVM hypervisor comes from. You don't see hypervisors on Intel stuff until the 90s. So that has literally like kind of 20 years difference. So all these ideas about virtualization, where do they start? On this platform. It works a lot different the ones they have now, but this is where it originally came from. Why? Because they had to. You had a centralized system. It costs a lot of money. You have to get as much utilization out of it as possible. And virtualization is the only way. What's this?
What is that?
Yeah, what is that? Yeah, go on.
Well, I just read
What?
the title.
Yeah, so you just read the title, but I say again, what is that? Looks like, yeah, that's right, a topology of a network. We know a name for this network. So this is the internet in 1973. Okay. And these are all the IBM 360 mainframes on the internet in 1973. So you see they've got some DEC PDP-10s, PDP-11s, but look how many IBM 360s are there. Yeah? So this stuff was the backbone. This stuff, we're talking about the OG stuff here. So one might say, and every now and again I hear this from some of you people, if these mainframes are so wonderful and so interesting and important, how come I don't know anything about them? And I'm going to say the rude things. I'd say, well, because they're so much part of the system, they're actually invisible. Right? When you use your banking app, you don't know you're spinning the wheels on a mainframe. When you get money out the wall, you don't know you're spinning the wheels on the mainframe. When you buy something through your Amazon account that's linked to your credit card, you don't know
you're spinning the wheels on the mainframe. There is a really cool essay called it's actually called something else, and I'm trying to remember, but I'll come back with it. But yeah, you do say like the eternal mainframe. That's it. I think I have links to it. So yeah, the step after ubiquity is invisibility. We rely on it so much that we don't even notice that we rely on it. So that's where they all are. They're hidden in plain sight. 1991, a fella called Stuart Alsop wrote this prediction that the last mainframe would be unplugged, and he actually gave a date, and it's almost, look at that now, that is almost 30 years to the day today, right? You say, yeah, the last one's going to be, the one phone's going to be switched off. And this is him in 2002, literally eating his words. Yeah. And I mean, I'm old enough to remember these days, there was this conversation where they go, well, now we've got these PCs, we've got like Ethernet, we've got like, client server. No one's going to use these mainframes anymore. But the truth was they were just so good at what they did. You can't just walk away from them, right? It's so much to do with the engineering points, but behind it. Yeah, and so the Z that we talk about, this was what they were renamed in the 2000s. The Z standing for zero Zion time. Sometimes we have these conversations about, oh, this is old, and you go, well, trains are old. Do we still have trains? Yeah, we have maglev trains. Go to China. They're building trains. It's all about the trains. It's the most efficient way to get freight at scale from one place to another. If you build a port and that's where the ships come in, you want some trains to get that off to get where it wants to go. Yeah, you might use trucks at a certain point. And this was kind of what Andre was saying about, it's kind of a concert of different types of technology in order to kind of get them to you. The last mile might be an app on your phone, but the backbone, the freightness of data, you want to carry that on a mainframe just because of the engineering points. Recommending this book for smart people called Kill It With Fire, and it's a conversation about how technologies get chosen and how they get discarded. Really nice lady wrote it, Marianne Bellotti. So this here talks a little bit about how the technologies that you think everybody uses now are actually ones that have driven increased use of the mainframe. So until everyone had mobile apps on their phones, when people didn't have mobile apps on their phones, mainframes are doing a lot less work. Now they do, and you can check your balance every 5 minutes. That's a load of work your mainframe is doing. There's a whole conversation about what happened during COVID when everybody was at home, and it's kind of, well, online payments and mainframes save the world. Had it not been for that infrastructure being there, what would have happened during those times? It's an open question. So some of these things are old IBM slides, and Andre's ones are much more up to date, and they explain kind of the role. Some stuff about quantum encryption. I think we talked about that a bit already. This was the predecessor to the 17. This was the 16. It had a Telum 1 in it, and it looked a bit similar, but the newer one is a bit more cunning. I think it's 5 nanometer technology. Yeah. So I think it was 7 in the 16, 5 in the 17, and they are going even smaller. And this is about the amount of complexity that you can get
on a chip. So really interesting times as these kind of move forward. And I mean, sometimes you have these conversations and people go, oh, isn't it old technology? I'm like, yeah, so how many nanometers in your x86 right now? Who designed that? Has that got on-chip inference, AI inference? No, you have to take it off the box, put it on a GPU kind of thing. So, you know, when people say old, it's like, well, okay, talk to me about old. You know, let's compare like with like. Yeah, all that good stuff. This is a picture of Talon 1. So one of the things it's worth explaining. So because it's enterprise computing, a lot of other architectures spend a lot of silicon on registers and potentially kind of doing maths in the ALU. Because we're talking about business computing, we're not trying to render shapes or kind of do kind of physics calculations. So we actually use the same silicon, but differently. And in particular, we use it for caching. So we can take huge scoops of memory and we can apply some either very simple logic processes to it, or we can do that inference stuff. So we can say, here's a whole transaction. Let's see how that compares to what we're expecting and do those things there. So it's that you have the same materials, but you're actually using them differently. And that's one of the things that makes it behave in a slightly different way. This was something I was saying about people getting access to them online, but you don't need to do that because you have access to them via Z-Explore and you can follow through the badges. But sometimes people who are developing on the platform might want to do something with that. A little while ago, me and that Henry Kuiper were organizing an event where people were using a WASI instance to take part in Advent of Code. Have any of you taken part in Advent of Code?
Just one people.
Righty-ho, the rest of you, shame on you. Look it up. Advent of Code. Get stuck in. You don't recognize this. This is a time sharing option, TSO, just kind of showing what it looks like to kind of log in. There is a whole insider's world of being a mainframer, where once you've seen 3270 and you know what they look like, you start seeing them everywhere. So you'll be like in the queue at Costco and you go, oh, I know what that is. I was at the bank one time. I went, oh, there you go. And the guy said, yeah, it's something called DOS. I said, no, that's a 3270. I know one when I see one. So yeah, it's a whole different way of thinking about interacting with systems. So these are the things that they might look like. I mean, I don't want to bang on about them. I suggest you get stuck in and have a little go yourself. If you are readers, and perhaps you should be, there was a very good book called Modern Mainframe Development. I know some of the guys that made a contribution there. It is worth looking up. Have a chat with your subject librarian. Maybe they could order that in for you. The Bibles of mainframes are the red books. So you're going to ask them.
I was going to say, can you use it as an active or early subscription for students?
Yeah. Good. See if you can find it there. Yeah. Check for me. I don't remember finding it on there, but there are ways of finding it if need be.
Lucy, can I think request that you need to order one for you?
Yeah, that too. So yeah, you have these Bibles where you can kind of look up all the tech and how it works and the alphabet soup of acronyms and variables and all the things that kind of live behind it. So if you're so inclined, I recommend having a little bit of a go at that. This was an old link to the Z-Explore platform. You've seen a much better link than that. This was something about the whole
open mainframe project, which was spun up in 2015 as a group to decide what Linux was going to be when running on mainframes. Now, Linux on System Z has quite an interesting history in that originally it was a student project that was happening at IBM Bodlingham. So it's one of the places where they make IBM Z. So you've got Bodlingham, you've got Poughkeepsie, and there's a place in Singapore as well that they kind of put them together. And so there were some students, and it was like a summer project. And they said, well, we've got this machine, and we work with Linux anyway, so maybe we could see if we could port Linux over to the mainframe platform. And that was basically the start of it. Now, funnily enough, if you go to the Open Mainframe project, there are only 2 universities in the UK who are officially members of that project. Can you guess who they are? Close. I haven't twisted Hertfordshire's arm yet, but when I was at Bedfordshire, I made them join. But yeah, Wolverhampton is the only university in the UK that's officially a member of the Open Mainframe project, and it took me many hours of sitting on the Vice Chancellor's secretary's desk saying, "Can we just get this signed? Is there not a way to do that?" And there are a lot of interesting projects that live underneath the Open Mainframe project. Stuff about COBOL, stuff about blockchains, stuff about a graphical user interface called Zoe. So it's a real box of marvels. So the Mainframe Society was a kind of a social group started by my mate Henry Coipler, who came over that time to do that session with us. And they are keen to kind of encourage new talent. So the guys who are involved with Waves are part of that. I believe, if I'm not mistaken, 1 or 2 of you came to a Mainframe Society event in Birmingham and ended up going to a very posh restaurant after I left and had to go home. That was the story I heard. I missed out on a feed. But yeah, that's another source of information and stuff to do. So there are some links. I'm sure you can find those yourself, or I can send some up-to-date ones to your local ambassadors, and maybe you'll find something interesting to do with them. But apart from links, I thank you, and let's Let's have some questions, people. What can I tell you? What can I tell you about this platform? Go on. Come on, let's go.
Who wants to fight?
So there's the skills depot.
After skills depot, so.
Yeah, I mean, where can you find a job?
Because
Anyone that uses the
he's
platform.
finished his Z Explore. He's almost done with skills depot, and he doesn't know.
Go to the Mainframe community board.
So there's maybe
But the problem is, we're internationals. It's a bear, me, and most of them.
But this is the thing. So mainframe is an international technology. So people often travel with it. So I know people in Germany doing mainframe, and their Z skills are valid here. And there's people in the Philippines doing mainframe, and often they've moved to Germany because of, kind of just how they move around. There's lots of Z going on in India. We have the whole nearshore thing, where there's stuff going on in Lithuania. I mean, one of the reasons that I kind of like to promote it here and to put it to international students. We had this question about the badges. What do you get out of the badges? Think about it. You get smarter. You get smarter by doing the badges, by learning about mainframes and doing mainframe stuff. You get smarter. You're a more interesting person. When you rock up at an interview and people ask you, so what have you been up to? How have you been spending your time? You've got an interesting story about stuff they may not know about, which makes you look smarter. And if they do know about it, they're quite impressed that you know about it too. So this is the thing. That's what you get out of it, becoming a more interesting person. And you can find that all kinds of places. So it actually took me quite a while before the first students that I worked with started to get roles on the platform. But I noticed that the ones that got involved with this and learned about it did better anyway. Just because it meant they had sharper brains, they were learning things about, you know, kind of meeting industry people, how you dress, how you talk, you know, kind of how to be serious, kind of face to face. It has never done anybody any harm. In fact, it's only ever done people a heck load of good. So that's why I say get stuck in. Specifically to that question, when you've done the depot stuff, I would say start becoming a committer on the Open Mainframe project. So look at some of the projects, start developing some code, start taking part in the forums. It's something that you use actively rather than you apply passively. It's you know, once you've got the skills, let's get out and do something with them. Show them off. So I hope that answers your question.
Yeah, it does.
Good.
I think that's the most stuff on me as well.
I know.
Yeah, it's for a lot.
Yeah. No. It's for the people who are shy. I get that. And see, this is the other thing. You see, look what they just did. These are leadership roles. These are people who have leadership roles with a Fortune 500 company. How many of you can say that? Put a hand up if you can. You see, it's only you guys. So it brings you into contact with ideas, with training, with opportunities that you probably couldn't get any other way. Yeah. Okay, so I mean that's kind of what I kind of wanted to say. I don't want to get between you and the pizzas. So if you have any other questions, catch me as I'm eating. I do eat with my mouth. I do talk with my mouth.
So this part is just socializing, and there's Uno, we can play games or anything. So yeah.
We no longer do the karaoke. Once upon a time, we were famous for our karaoke.
Should I play karaoke? Feeling pretty. Thank you.
It's okay. We're not gonna be mean to Brother Andre.
Yeah.
Come all this way. Let's not.
We just like to enjoy it, sure.
So we wanted to come back sometime. We don't want to.
Feel a bit bored of your old songs though. How old are you, Dad?
Very.
10 times older than me.
Yes, I think so. Put a 0 on your age, and that's my age.
So you're 190.
Something like that. Yeah.
Thank you guys for joining online. It was a good meeting.
Thank you. Cheers. See you. Bye.